Hello students, today we'll be starting a new chapter known as quadratic equations. Now quadratic equations is a chapter that is somewhat connected to the linear equations chapter. You might remember in that chapter we focus on x and y and then solving equations where we have x and y in 2-3 equations. But the key thing was the highest power was always 1. Just x, just y. We don't have anything else. In the quadratic equations chapter, we will instead have equations like x square plus 5x plus 6 equal to 0. Here, the maximum power of your variable is 2, as we can see in x square. And we will only focus on single variable equations. We won't have x and y. The main focus of the chapter is solving these equations and finding what is known as the roots or the zeros of the equation. There are 3 primary methods. The first being the splitting of the middle term method, something which you have seen in junior classes. You have completing the square method. This we will go through it and understand what does it mean. And through the completing of the square method, we get to the discriminant method. And this method is what is a formulaic method. One in which you don't need imagination, you can just plug in your values and get your answer. So let's start looking at what is a quadratic equation and how can we start solving them by these methods. So starting off with the splitting of the middle term method. In this method, all you have to do is look at your quadratic equation, analyze it and proceed in the following way. First thing you will do is look at your constant term, which is plus 8, you look at it with the sign, and look at the coefficient of x square. In this case, it's simply plus 1. And you multiply them. So 1 into 8 is 8. Now your job is whatever that product is, in this case plus 8, you will find which factors of it when added together give you the coefficient of x. As in 1 and 8 are factors of 8, but 1 plus 8 is equal to 9. That is not equal to 6. 2 and 4, 2 into 4 is equal to 8 and 2 plus 4 is equal to 6. So in this way, I can rewrite the equation as x square and then the 2 factors we found, 2 and 4. We will break this 6 as 2x plus 4x. X square plus 2x plus 4x plus 8. Now we can clearly see I can take something common from here and something common from here. From here, I can take x common. In the bracket, I'll be left with x plus 2. From here, I can take 4 common. In the bracket, I'll be left with x plus 2 because 4x and 4 into 2 will be 8. Now clearly, from both of these expressions, I can take x plus 2 common. So I'll be left with x plus 2 into x plus 4, and this is your factorized form. Obviously, when I will set this equal to 0, I'll end up getting that x is either negative 2 because it will become minus 2 plus 2 0 into something which is 0, or x is negative 4 because minus 4 plus 4 is 0 into something which is 0. This is the splitting of the middle term method. Depending on what your factors are, you will have to figure it out. Both your c and coefficient of x square product as well as your coefficient of x. For example, if I simply change this to being x square minus 6x plus 8, you might wonder, 8 has positive factors. Not necessarily. Minus 2 into minus 4 is also equal to 8. So in fact, we can see minus 2 plus minus 4 is minus 6. So clearly this would become x square minus 2x minus 4x plus 8, which will simply become x minus 2 into x minus 4 when you proceed in the same way as this. So this is your splitting of the middle term method. You have to look at your values and appropriately figure out what is the correct factorization. Because this method requires imagination, it's not a great method to use for complex equations. So now let's look at the completing of the square method. The second method is the completing the square method. This one requires less imagination. What we are going to do is, if this is my quadratic equation, obviously if we are solving it, it is set to 0. Now, this is x square plus 6x. I know that if I do x plus 3 whole squared, I am going to get x squared plus 2 times x times 3, 6x plus 3 squared. So see, I'm getting x squared plus 6x. So I am going to rewrite this equation as x plus 3 whole squared, which if I open it up will give me x squared plus 6x, but it will also give me plus 3 squared. So I will subtract 3 squared, so that if I open up this whole thing, I will get back to here. And obviously I will be left with plus 8 equal to 0. Now this is a perfect square and I can shift my values to one side and solve. So leaving this over here, I will take minus 9 plus 8 to the other side, which will become plus 9 minus 8, which means that x plus 3 whole squared is equal to 1. Now I will take the square root on both sides. This will simply become x plus 3 and this will be the square root of 1, which happens to be 1. The only thing you have to remember is you will write it as x plus 3 is equal to plus or minus 1, because when I take square root on both sides of my equation, one side is left as it is, one side is written like this. What it means is when you finally shift your minus 3, your 3 to the other side, you will get two answers. One answer will be minus 3 plus 1 and the other one will be minus 3 minus 1, which we are getting as minus 2 and minus 4, which is the same as what we got by splitting the middle term. This is completing the square method. Always get your x square coefficient to be equal to 1. You can divide your equation, let's say it was 2x squared plus something. You divide throughout by 2, you will get x squared. Find whatever the coefficient of x is, accordingly take your whole square. Subtract the square of the constant term inside the bracket, add whatever your original, add or subtract your original constant term and proceed. This is how you solve a question by completing the square method. The only time we'll use this method is if we are asked to do it, because using this we are going to see the discriminant method, which is a far superior and far more straightforward way of finding the root. So let's look at that now. Finally, the discriminant method. In this one, we just have a formula. Let's say that my quadratic equation is ax squared plus bx plus c equal to 0. First, we calculate this thing known as the discriminant, which is simply known by the letter d. And your discriminant is equal to b squared minus 4ac. This is your discriminant. You will calculate this. If this comes out to be positive or 0, then you will proceed. If it comes out to be negative, you will simply say that the equation has no real roots. Why? Because the formula is that x is equal to minus b plus minus the square root of the discriminant divided by 2 times a, the coefficient of x squared. Clearly, if d is a negative number, we are trying to find the square root of a negative number. We know that that is not possible, so we will say there are no real roots. Similarly, if d is 0, this will just become plus minus 0, so we will get only one root, which is minus b by 2a. And finally, if d is positive, then we will get more than one root. So using our same equation, x squared plus 6x plus 8 equal to 0, here this is 6 not b. My discriminant is b squared, which is 6 squared, minus 4 times a, which is 1, times c, which is 8. This is nothing but 6 squared, 36, minus 4 into 8, 32, equal to 4. This is my discriminant. It is a positive number. So x is equal to minus b minus 6 plus minus the square root of my discriminant 4 divided by 2 times the coefficient of x square, which is 2. This is nothing but minus 6 plus minus 2, square root of 4 is 2, upon 2, which will be minus 6 plus 2, minus 4 upon 2, or minus 6 minus 2, minus 8 upon 2, which is again minus 2 and minus 4. So we have again got our same answer. So these are the three methods. This method is the most formulaic, it's the most straightforward. As long as you remember the formula, you will always get your solution. And it also helps you determine the nature of roots, whether they are real and distinct when d is positive, real and equal, meaning you have only one root when d is 0, or no real roots when d is less than 0. So if you remember these three methods and these three formulas, you can tackle anything in quadratic equations. So now let's move on to the next chapter.